Good morning. So previously we have been learned a similar problems related to the reflexive, transitive and the other things, right? So here it is little bit different. Here we are mentioning about the geometrical shape, how it represents the reflexive functions and transitive and symmetric functions. Let us know about the questions. So what they have been given the question, that is show that the relation R on the set A. They have been defined a relation on the set A of all the points in a plane. Means what? Since I have been got a plane here, in that each and every points are belonging to the set of points A. So, as the relation has been defined as P comma Q, distance of the point P, means distance of the point P from the origin is same as the distance of the point Q. Means what? That is, whatever the distance from the origin to any of the point P is equal to each other. That is, OP is equal to OQ. Okay, so is an equivalence relation. So the first question is, you need to solve that both the distance from the point P to the point Q is an equivalence relation. According to this function, so let us learn about few things here. Let us consider a plane here. So let us consider a plane. Here, the plane defines that each and every points are belonging to the set A. So then how can I prove it is a reflexive function? Just observe here, if I take one point, if I consider the point P, this is the only point which shows its own replicative, right? So, the point P is only the point P which can have the distance from the origin to that point. So, therefore, we can, according to this, we can write it as the solution given by solution. So what is the solution? So reflexive condition, what does it says? Reflexive means A comma A should belongs to R. A comma A should belongs to R, which is the point I have been considered only P. That is P comma P belongs to R means, what does it means? OP is equal to OP only. That is the point P which is similar point having its own reflexive is nothing but its own point only. So which belongs to R only. So therefore we can say it has, therefore it is an reflexive. It is an reflexive. So since the reflexive condition has been proved, next go for the next type. Which is the next type here? Symmetric. So what does the symmetric says here? OP, that is P and Q is having the same distance. As the question only it is defining both the points are involving to each other, means each points are belonging with the same distance of the point. So according to this, I can directly write it as A comma B belongs to R means obviously P comma Q also belongings to R. If P comma Q is belonging to R means what does it says? OP is equal to OQ which belongs to the point, which belongs to the relation R. So the first condition has been proved. If A comma B belongs to R means obviously we have to say that B comma A also belonging to the point of R. If B comma A is belonging to R means we can say that Q comma P also belongs to R. If Q comma P are belongings to R means what does it says? OQ is equal to OP only. So OQ is equal to OP which belongs to the set of R. So now this proves the condition of which condition? Symmetric. So therefore it is an symmetric condition. Symmetric condition. Next one is transitive. So what does the transitive function says here? Transitive says that A comma B belongs to R means A comma B belongs to R means obviously B comma C should belongs to R. Then you can say that A comma C also belongs to R. Here we have been considered 3 points. The majorly first two functions we have been considered only 1 point and as well as the 2 point. Here we need to consider in a plane if there is another point R is present means obviously if both the points are equal to each other means next the other point will be also having the same distance for the point O to R. For example, let us consider the distance from here to here 10 centimeter means and here also the distance will be 10 centimeter. If both are on the distance of the same element of the set that is 10 centimeter means all the 3 points are lying from the origin is 10 centimeters only. So according to this we can prove for the next thing, that is what does it says that A comma B belongs to R means that is nothing but P comma Q which belongs to R means so that is we can say that OP is equal to OQ. OP is equal to OQ. If Q comma R belongs to R, if Q comma R which is belongs to R means, so this OQ is also having a 10 centimeter means obviously the R is also having the same 10 centimeter. So if OQ is equal to OR means both are similar to each other, that is P comma R belongs to R means we can directly say that OP is equal to OR. Therefore, it is an transitive. If all the function, if all the types of relation is satisfied means what does we call it as? It is an equivalence relation. Therefore, it is an equivalence relation. So this satisfies the function of equivalence relation. According to this, there is another questions which has been defined. So what they have been told, further show that the set of all points in a point P is not equal to 0 at the coordinate, then it is a circle passing through P with the origin as a center. Obviously, observe the plane. So, if all the points are having the same distance of the point from the origin means, if I make it some kind of angle, here I have been considered n number of points. N number of points means what kind of shape it is occurring. It is a circle. Why means from the distance of point P to this origin, it is having the same equal number of distance in each of the point. So what happens if you kindly generate these points all together, you will get a circle. So therefore you can directly say it has, what does you can say, therefore it is a circle. Why it is a circle? Because OP is equal to OQ is equal to OR, which defines, what does it defines? Radius, which defines a radius of a circle with equal distance, that is what radius says, right? So if you take from the center of the point, you can mark with any kind of the circle of the given inside of the circumference of a circle. So each point from its origin to the point of the circumference of a circle having an equal distance in each of the point on the circumference of a circle, we call it as a radius, right? You can take any point. You can take this point, that is, let us take some here. If it is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. So, till here. That is, if I take E point means from this to this having a equal distance with OF also. So OE is equal to OF I can mark. Why? Because both are in a radius of a circle. So therefore it is a radius of a circle. Each point on the plane is equal, has the same distance from the origin of the center of the given point. Therefore it is a circle. So this proves the theorem. Yes, the next problem says that show that the relation R defined in the set A of all triangles. Means what? They have been defining a relation. So what kind of R it is? A defined R in a set A. A set A of all triangles. Of all triangles means obviously it presents of equilateral triangle, right angle triangle, isosceles triangle. So these kinds of many triangles will be present in a set A. The common set is all kinds of triangles. Equilateral triangle, right angle triangle, isosceles triangle, isosceles triangle. So these kinds of many triangles will be there. So in that they have been given a relation. So what kind of relation they have been defined? That is, the relation has been defined T1 comma T2. That is, if I take any two triangles, the first triangle is similar to the second triangle. Means, what does it mean? Is an equivalence relation. So you will discuss about the equivalence relation you have been previously know. So first tell me that what is a similar from triangle 1 to triangle 2. So suppose I have a two triangle here. So the triangle 1 is having the sides of 2, 4 and 3. And second set is, when I compare to the first triangle, the second triangle is which is little bit more bigger. So according to this, so what does it says the sides here? 4, 8 and 6. So how can I make these two triangles are similar? So you have been previously known about the congruent. So what does the congruence says here? If your angles are similar means their sides are also similar, right? So that is what we defined as a congruent triangle. So suppose if I take the smallest side of the triangle has 2 by 4. That is in a ratio format. So which is equal to 3 by 6. Which is equals to 4 by 8. So just observe here, each and every portions of the two triangles which is getting the form of 1 by 2. That is 2 ones are 2 twos are, again 2 ones are 2 twos are, 2 ones are 2 twos are. Means what? If I take any two triangles which are similar means their sides and angles should be same, which comes into a ratio and proportion formats are equal. So that is, if I consider any two triangles, these two triangles having the same ratio and proportion format has 1 by 2. So according to this, they have been defined a 3 triangles. So which are those triangles? Triangle 1, triangle 2 and triangle 3. So according to this, we need to show that which are those two triangles are similar. Which are those two triangles are similar. Obviously we can say that T1 and T3 are similar. Why not T2? Because it is having a set of 5, 12 and 13, which is not possible, which cannot be divisible from T3 and T1. So by seeing that only we can understand which are those two triangles are similar. So let us prove first it is a equivalence triangle or not. Suppose if I consider a triangle 1 means, if a reflexive function has to show means it should have its own kind of things. That is, suppose if I take a small triangle means, if I defining with the another triangle means, the reflexive of the first triangle has its own reflexive, right? So that is, we can call it as, that is solution. So what does the solution says here? So for the reflexive, if A comma A belongs to R means So we can say that T comma T, that is any triangle of its own has its reflexive. So which belongs to R. Suppose if I take it for here, a T1 is an equilateral triangle, means somewhere some other kind of equilateral triangle with a bigger size may be present, right? So that is T1 or TT is equals to R, which belongs to R. TT is nothing but any kind of triangle has its own reflexive in the given set. R is similar. So therefore it belongs to R, means hence it is an reflexive. We define it as reflexive. Has the same we have been defined here. Now, what does the second condition says here? That is symmetric condition. So what does the symmetric condition says? The same thing. That is, they have been already defined in the relation R. So how it is defined? If I take any two sets of a triangle is similar, means how T1 is similar to T2. Right. According to this, I can directly write it as if A comma B belongs to R means directly I can write it as T1 comma T2 belongs to R. Why it is T1 belongs to T2 means that is T1 is congruent to T2. That is, you take any kind of triangles as I previously solved. Their sides are different. Their sizes are different, but the coming ratio is same. So if both are same, means I can also write it as B comma A also belongs to R, means T2 comma T1 also belongs to R. That is, we can say it as T2 is also congruent to the first triangle T1. So this is how you prove for symmetric conditions. Next, let us go for the another one, that is T3. So what does the T3 condition says? That is transitive condition says that transitive condition says if you take any three triangles, for example, let us consider another triangle has 4, 5, 6 or 3, 4, 5 is similar to the first triangle. Obviously, the condition proof says that A comma B belongs to R, means then T1 comma T2 is belonging to R. Why it is belonging to R means T1 is congruent to T2. So, I cannot say that both the triangles only congruent to own itself. There will be present another kind of triangle with different sides which is similar to this T2 form, right? So directly I can write it as B comma C also belongs to R, which is the B function. What is the B value it is having? T2 comma T3 belongs to R, means I can say that this T2 is also congruent to some other triangle T3. If both the triangles T1, T2, T3 are congruent, means according to the third condition, how can we prove that? That is A comma C belongs to R, means but obviously T1 comma T3 also belongs to R, which defines T1 is congruent to T3. Therefore, all the three sets of triangle are symmetric, transitive and reflexive. Therefore, hence it is and transitive. So if it is a transitive functions proves reflexive condition has been proved and as well as symmetric condition has been proved, means what does it defines? It defines it is an equivalence relation. So according to this, we can define both the relations are equivalence. According to this whole condition, there is one more condition you need to prove, which is that the condition says that let us consider three right angle triangles. Okay, they have been already given the sides 3, 4, 5, and T2 is having the sides of 5, 12 and 13, and T3 is having the sides of 6, 8 and 10. Which are those two triangles are related? As I previously proved here, in the same way you need to prove. How can I relate this? Let us consider here three triangles they have been given. So what is the T1 says? T1 says is having the sides of 3, 4, 5, and T2 is having the sides of 5, 12, 13, and T3 is having the sides of 6, 8, 10. Right. So how can I make this triangle which is the bigger value? For example, let us consider this T1. So which sides is having more value? That is 5 is more. So that is your hypotenuse. That is this form, hypotenuse. Okay. And little bit lesser than that is your base form. That is basement. And the opposite is your least form. That is the height which defines, that is 3. So according to these measures, I have written a triangles according to the given sides. That is 3, 5 and 4. Again, when it comes to T2, which is the highest one? Highest value is 13. 13 defines the hypotenuse of a triangle, and little bit smaller than the hypotenuse is number 12, which defines the base, and the last left out part is 5, which defines the opposite side of a triangle. Next, in the same way, T3 has been defined here. So 10 defines the hypotenuse, and little bit smaller value is 8, which defines the base, and the next highest little bit smaller than base and hypotenuse is number 6, which defines an opposite sides. According to this, how can I make each and every triangles are related? So I have told you, if T1 is similar to T2 means their side should be equal. Let us make a column, that is T2 is symmetric to T3, and in the same way T1 is similar to T3. So let us take when you're defining any two triangles, the sides of the given value has to be divided with the same sides of the given set. That is, if you're taking a hypotenuse or if you're taking an opposite side of any two triangles, it has to be divided with the same opposite side. That is, we can write it as 3 divides the value with 5, which is equals to, next, if I take the basement means 4 divides 12. If I take a hypotenuse means, which is the value will be left? 5 divides the value of 13. So is it possible? Is it possible to divide? That is, you will get the value of 1 by 3. Is this term is giving, both the terms are giving 1 by 3? No. So therefore, T1 is not symmetric to T2. Got it? In the same way, let us do for T2 is symmetric to T3. Is it possible? Let us check. So 5 by 6 is equals to, next 13 by 10. 13 by 10 is equals to 12 by 8. 12 by 8. So what is the value? 6 4 3 2. So directly we can write it as 3 by 2 value. Is the value of 5 by 6 is equal to 3 by 10. 13 by 10 is equal to 3 by 2 value? No, it is not equal. So all the terms are not equal to each other. Therefore, T2 is not symmetric or similar triangle to T3. Now let us check it for triangle 1 and triangle 3. So what does the triangle 1 says here? 3 by 6, which is equals to 5 by 10, 5 by 10, which is equals to 4 by 8, 4 by 8. All the terms should get a similar value. Let us check. 3 1s are, 3 2s are. Yes, the term 1 by 2 is equal. Next, 5 1s are, 5 2s are, 1 by 2, which is equals to 4 1s are, 4 2's, that is 1 by 2. So each and every terms are equal. So we can write it as T1 is related to T3, that is T1 is similar to the triangle of T3 for the given sets of relation. So this proves the theorem.